All right, good morning, folks. Welcome back to Algebra 2. Today, we're going to do a couple things. We'll go over the answers for yesterday's worksheet. I'll introduce the chapter review, trying not to spoil too much of it, and give you a chance to look over and ask questions and just work on the review. It's just review workday. Because you have a test coming up on Friday. Okay, so Friday's class will be test taking time. It is all electronic online using the quizzes format. Let's see, what else you want to say about that? I don't remember the details of how I set up your last one, so let me just explain what this one is, and you can do the compare and contrast yourself. So there will be 20 questions. You will have 3 attempts total to take it. So I'll start you off with one. Everybody will start in class with 1 attempt, and then I will leave the test running for a total of 2 days. So you'll have Friday and Saturday till the end, till like Saturday night, to finish up to 3 attempts, if you so choose, to try to improve your score there. The questions are randomized, taken from a larger pool of questions, so every time you do retake the test, you are not guaranteed the exact same set of 20 questions. Okay? If you do get the same question, though, it does have the same right answer. Let's see, anything else about the test? Quiz is 2 days, 20 questions, 3 attempts. Yeah, that's it. That's the test in a nutshell, okay? So, without further ado, let's turn to our worksheet from yesterday, the exponential growth and decay problems. And yes, I hit the right button this time. Here are corresponding answers to the first page. Fishing, it'll take about 8.3 years to get the population down to half, or to reach the half from before, right? Investing, it'll take about 10 years to get your investment up to $3,600. Again, an account that has a 6% return is ridiculous. That's nonsense. That doesn't exist. You will never get 6% back on your money from sitting in a bank account. No such account exists. Anybody who tries to sell you one is lying. It's a scam. Don't give them your money, okay? The only way to get anything close to 6 is with a market type investment. So something with a little bit more risk. A CD, certificate of deposit, you can maybe get like 3%, but like a basic savings account, an account that is 100% safe, okay? You are never going to lose any money, and that is 100% liquid, okay? A savings account, you can go to the bank at any time and withdraw any amount you want from it. That's liquid. You're going to be stoked to find an account in like 1%. I think you can get like some online banks offer like 1.2% interest. That's the best possible. Okay. Go over number 4? Sure. Okay, so 3 was 5.5 million. 4, population P in thousands of a city can be modeled by the equation P equals 80 times e to the 0.015 t, where t is the time in years. Remember, this is always like years passing, okay? Don't like actually plug in 1981 in your time for t, okay? How many years since the events? So the question is, in how many years will the population of the city be 120,000? Yeah, 120,000. Okay, population P, plug in 120,000. Here for P, you already have the rest of it. Clearly they started with 80, and we're just solving for T. So at year 0, there was 80 people, and they're growing exponentially. So to solve for 120. So we're going to have 120, wait, P is in thousands. Ooh. It's not 120, it's 120. That's the catch. That's the tricky bit right there to miss that. We want 120 divided by 80 will equal e to the 0.015 t. Solve for t from there. So you will just ln both sides and divide by point. So t should be ln of 120 divided by 80, all divided by 0.015, if I'm getting my order of operations correct here. Is that what 3? Did you miss the thousands? Because if you were looking at, okay, go from 80 people to 120,000 people, that's going to be a long time. No. It's from 80,000 to 120,000. Much more reasonable. Got it? All right. Okay, so 5 then, 4.9 days for the bacteria to grow. Number 6, the element plutonium-239 is highly radioactive. No touchy. Nuclear reactors can produce and also use this element. The heat that plutonium-239 emits also has helped to power equipment on the moon. If the half-life of plutonium-239 is 24,360 years, what is the value of K for this element? Ooh, half-life solved for K problem. This is just like this is not just like this one. I thought we had an example. Was it not on here? We did it ourselves, didn't we? Yeah, this is the example that I did in class. So we're going to use the this equation up here. We're solving for K. This 0.015 was our K, right? So we have, P equals A times E to the K T. That's growth. This is decay. It is depleting, so it's negative KT. We don't care what A and P actually are. We only care about the ratio of them. So when I divide both sides by A, my P over A is 1/2. So set that equal to E to the negative K times our time, 24,360. Okay? Natural log both sides. Divide by negative 24360. So K should be equal to ln of 1/2 divided by negative 24360. And that will give you a positive number. If you recall, your natural log graph goes like that, and it crosses here at 1. So anything, the log of anything less than 1 will be a negative number, so you'll have a negative value divided by a negative value. Perfect, back to positive value for K. Not a very big number, but a positive one. And then there is 7 and 8. Any more questions from the front page? looking like the natural log ones are giving you the most trouble. Which is a shame, because natural log is so beautiful. You'll learn to love it. You really will. Especially when you get to calculus. Don't worry. All of a sudden, natural log is the most amazing thing ever because it actually simplifies everything. It's the easiest function to work with. But not yet. That's why we practice. Okay. So then over here is page 2. So if you went above and beyond and finish the backside, then you'll have these problems. Here are the answers for each of those. Look at this, radioactive decay. Find the constant K. Radioactive decay, what is the value of K? Notice that every time I'm going to set up this same equation. I start with my basic continuous growth decay equation, or decay specifically, right, with a negative. I'm always looking for half-life. When will I get half the original amount? So it's just 1/2 equals e to the negative kt. Solve for k. I will always, if you want to work it out, right, this is your shortcut. You will uncover that k will always be ln of 1/2 divided by negative t. So whatever your half-life time is, this formula will get you k. All I did was take the original, this, solve for k. You'll always end up right there. We have whales, more population of rabbits. I don't know why this is about whales. This is about carbon dating again, but whatever. Depreciation of computer systems and biology. Okay. Questions on that page? All right, then let's go back to, so your chapter review. Please ignore the answers. I'm just going to clear that. I'll undo it later. Okay, I don't want to spoil it for you. I will post the answers tomorrow morning. All right? So answers to the review will be posted tomorrow morning, so you can start on the review problems tonight, check your answers tomorrow, and review. I'm going to space it out for you. All right? So we've got recognizing growth. We've got writing a growth equation, writing an exponential function with 2 points. That 0 is your friend. Make use of it. Solving just basic exponential equations there. Switching from log to exponential and back and forth. Evaluating logs. Okay. Remember 2 ways to do that. One, you can do it in your head if you know the powers, right? If you know the rules, right? Matching bases simplify things greatly. Okay. You're looking. Try rewriting it in the exponential form. See if that makes it more explicit. Oh, 3 to what power is 81? That kind of thing. And then solving these ones for the indicated variable. These are not using the change of base formula yet. Okay? Evaluate these using powers, your known squares and cubes and 4th powers of numbers. These ones are often the most tricky, using given approximations to evaluate given expressions. So you're trying to rewrite, use the log rules. How can I rewrite log base 9 of 28 as a combination of, notice it's still log base 9, log base 9, log base 9. So how can I rewrite log of 28 as a combination of log of 7 and log of 4? Well, first ask yourself, how do I make 28 out of 7 and 4? Okay, if I do that to the arguments, what do I do to the log expressions? Use those log properties there. And then whatever you're doing to those logs now, you can do to these approximate decimal numbers. And solving each equation, same thing. Get down to one log on both sides. Right? Check that you have the same base, which I think most of these do. Log 2, 3, 3, 3, 5, 5, 5. Get to one log on each side. Right? Then if you have log of the same base on both sides, log property says you can equate their arguments. So, for example, since we already have log and a single log here, oh wait, this is not a single log. This is not log by itself. It's got to be only log of stuff. So first we got to remove this 1/3. You can't just multiply both sides by 3 because then you'll have a times 3 over here. It doesn't help you. But there is property, a log of something with an exponent, you can write in front. We're going to use that backwards. Instead of 1/3 log of 27, we can rewrite this as log of 27 to the 1/3 power. Now it's single log on both sides. So now I can get rid of the logs and say y equals 27 to the 1/3 power. Okay, don't forget about those properties. And same rules apply down here on the exponential versions. And now we get to common logs. This is where you're going to use your change of base property. Okay, remember that the old bubba base goes on the bubba bottom of the new fraction. ln, same thing as before. It's just the base is now e, doesn't make a difference. And then we have some growth and decay word problems like we just reviewed. I won't reiterate the same tips I just said there. Okay. I've got it all on video now. You can pause, go back, rewind, and listen to it again. All right. Any initial questions of the review, about the review, from the review that come to mind with this overview? Overview of the review. No? All right, then I already went over details of the test, so I think I'm going to call that good. We'll end the stream there, and you